Most of us know what a lifetime of smoking can cause: lung disease, heart disease, premature ageing of the skin, and a range of cancers, everything from throat cancer to bladder cancer. However, since most diseases caused by smoking show up later in life, young people often assume that their smoking is relatively harmless, but recent research suggests otherwise. When doctors cut open the main artery from the heart, the aorta, they can often tell if the person was a smoker by the presence of atherosclerotic material inside the aorta. This can be true for someone as young as 15 years old. Now, if you're wondering what atherosclerotic material looks like, well, check this out. Glad you asked? Although the more you smoke, the greater the health risks, it all starts with just one cigarette. So in this program, we're going to look at how smoking one cigarette can affect the human body. You may not be aware of it, but there are many different physical responses, and we can demonstrate this using testing equipment. This is Dr. Rob Roseby. He has extensive experience in looking after young people with respiratory illnesses, and he'll help us with our tests. We're going to test 5 young smokers who haven't smoked for 12 hours prior to the testing. We'll perform the test twice on each subject, once before smoking a cigarette and then after smoking a cigarette. By comparing the results, we can show some of the physical changes that occur.
The first test we're going to do with Ollie here is simply measuring his blood pressure. Blood pressure measures the pressure against which the heart has to pump to get blood around the body. In general terms, the higher the blood pressure, the harder the heart has to work. Ollie's blood pressure is 115 on 70, which is normal for a male of Ollie's age. He'll now go and have a cigarette, and when he comes back we'll measure his blood pressure again. Ollie has just come back from having a cigarette. I'll measure his blood pressure again. Well, Ollie's blood pressure is now 135 on 85, which is significantly higher than it was before. This means that his heart is now pumping harder to get the blood around his body, and this difference is accounted for by the nicotine obtained from the cigarette.
Most of the short-term effects of cigarette smoking are caused by nicotine. Nicotine occurs naturally in the tobacco plant, and it's the substance that smokers become addicted to. If cigarettes had no nicotine, very few people would smoke, as most adult smokers wish they could stop. Nicotine is highly toxic. A fatal dose of nicotine is as little as 40 milligrams, and one cigarette typically provides about 1 milligram. When a smoker inhales, nicotine is absorbed into the bloodstream through the huge surface area of the lungs. It then travels in the blood to the brain and muscles. Special cell formations in the brain and muscles, called receptors, recognize and react to nicotine. This reaction triggers a wide range of physical responses, including a rise in heart rate and blood pressure.
The test we're going to do with Lucy here measures the flow of blood to her skin. What we have is a probe on her finger, which puts a laser into the finger and measures the laser beam coming back. That information goes up to the machine here where it's converted into a number, and we can see here that she's measuring in the low to mid-20s. That information then gets passed through these wires to this machine here where that number gets converted into a graph. Now that we've recorded this baseline information for Lucy, she'll go and have a cigarette, and when she comes back in a few minutes, we'll do the test again and we'll see if the cigarette has made any difference. Lucy's come back now and we're doing the test for a second time, and we can see that the results are markedly different. Whereas before the blood flow to Lucy's skin was measuring in the 20s, now the level is measuring around about 5 or 6. This difference is very nicely demonstrated on the graph. Before the cigarette, the blood flow was written on the graph in black ink, whereas after in red ink. We can see that the two measurements are poles apart, and that difference is largely accounted for by a change in blood flow caused by nicotine in Lucy's bloodstream.
Here we can see the effect that nicotine has on circulation. Nicotine causes blood vessels to constrict or clamp down. The constricted blood vessels allow less blood flow, and areas, such as the extremities, get a reduced supply of vital oxygen and nutrients. This restricted blood flow continues for some time. Studies show that one cigarette can reduce blood flow to the fingers by approximately 50% for up to 50 minutes.
The test we're going to do with Tony here looks at tension in her muscles. We're going to be looking at that by demonstrating the amount of tremor in her hand. What Tony is going to do is run a copper loop backwards and forwards twice along a metal rod, and basically the greater the tension in her body, the greater the amount of tremor in her hand, the more she will touch the metal rod with her copper loop. The information that comes from this device will be passed through to the computer and the results will be processed. Okay. What we see here is the results of the test. It took Tony about 24 seconds to complete 2 loops of the circuit, and which means it took just under 12 seconds for each loop. Importantly though, the error rate was only 2.3%. This means that she spent only 2.3% of the time with the copper wire in contact with the metal rod. It'll be interesting to see what the results are after she has a cigarette, and we'll find that out in a moment. Tony's back now. Let's see how she goes when she does the test again. Go. Tony's done the test for a second time now, and look at the difference in results. She took about the same length of time to do the test, 23 seconds this time compared with about 24 seconds the first time around. But look at the difference in the error rate. She has an error rate this time of 14% compared with just over 2% the first time around. This demonstrates an increased tension in her body or an increased tremor in her hands, and this is accounted for by the increased level of nicotine in her bloodstream.
Many smokers claim that smoking a cigarette relaxes them or reduces their stress levels. In fact, nicotine is a stimulant, which at times can also stimulate the part of our brain that makes us feel good. What smokers think they feel may not accurately reflect what's actually happening in their bodies. As we've seen in our test, nicotine can increase muscle tension and tremors.
What we're going to do with Ben now is a test of his lung function. What Ben needs to do is take a breath as deeply as he possibly can, breathe out as far as he possibly can, as fast as he possibly can. And this information is going to be transferred through to the computer, which will analyse the speed and the volume of his breath, and it will print it out as a graph. So pop that on your nose. Just have a few normal breaths through that to start with. Ben has normal lung function. Let's see what it's like after he has a cigarette. Let's repeat his lung function test. Ben's lung function test is now clearly abnormal. He has some constriction of his air tubules, and this affects his ability to move air in and out of his lungs. This difference is caused by the many irritants in the cigarette he's just smoked.
Our bodies react to the flood of noxious chemicals in cigarette smoke by clamping down the airways to the lungs. When this happens, smokers have greater difficulty getting air in and out of their lungs and will eventually feel short of breath. This response is particularly strong in asthmatics, although all smokers experience it to some degree. Incidentally, smoking low-tar cigarettes won't necessarily lessen lung irritation. Because low-tar cigarettes also contain less nicotine, many smokers, often subconsciously, take more frequent puffs and inhale the smoke more deeply into their lungs.
The test we're about to do with Helen now is measuring carbon monoxide in her lungs. Carbon monoxide is a poisonous gas which comes from burnt carbon materials. It comes out of chimneys, it comes out of car exhausts, and it comes out of cigarettes. We're going to measure the amount of carbon monoxide from Helen's lungs. We'll measure it in parts per million. The way we'll do that is we'll get Helen to take a deep breath in, hold her breath for 15 seconds, and then breathe out slowly into this machine, and then we'll see what result we get. Okay. Helen has 1 part per million of carbon monoxide in her lungs. This amount is negligible. I think it's going to be very interesting to see what result we get after she has a cigarette. Let's see how much carbon monoxide is in Helen's breath now. Okay, breathe out nice and slowly. Helen's reading is now 16 parts per million, and that's a significant increase from 1 which she blew before. And that's the effect of having just 1 cigarette.
Carbon monoxide is an odourless, tasteless, poisonous gas that's produced as a cigarette burns. Between 2.7 and 6% of cigarette smoke is carbon monoxide, and as we can see in the test, a significant quantity is absorbed by the smoker. Carbon monoxide is absorbed into the bloodstream through the lungs and then attaches itself to the blood molecule hemoglobin. Hemoglobin is a substance that carries oxygen around the body. Carbon monoxide binds to hemoglobin more strongly than oxygen, displacing it from the hemoglobin. So rather than carrying oxygen that the body needs, the blood carries carbon monoxide. This reduces the blood's ability to transport oxygen effectively, so every cell in the body has to work with a reduced supply of oxygen. This means that more effort is required during physical activity to achieve the same results as a non-smoker, especially during rigorous exercise. As we've seen, a lot of nasty stuff happens when someone smokes a cigarette. The tests we've done highlight some of the more obvious changes caused by the cocktail of chemicals in cigarette smoke. Everywhere we look in cigarette smoke, there's something doing damage to some part of the smoker's body. While it's easy not to worry about illnesses that may develop as we get older, smokers need to understand that every cigarette they smoke has an effect on their body. And we've only talked about nicotine, tar and carbon monoxide, 3 of the 4,000 compounds in cigarette smoke. There's hydrogen cyanide that damages the tiny hairs in our lungs that clean out contaminants. There are polycyclic aromatic hydrocarbons which cause cancer. There are metals like arsenic, cadmium and nickel.